So moving on to the joints of the hand, now we've looked at the wrist. The hand is anatomically comparable to the foot in so much that the bones are divided both into anatomical and functional divisions. So we have the carpal bones, the metacarpals and the phalanges. In the foot we have the tarsus, the metatarsals and the phalanges as well. And the muscles that control both the foot and hand can be found both intrinsically and extrinsically. The extrinsic muscles of the foot being, or the foot or the hand, being those muscles that have got a proximal attachment outside the boundaries of the hand, but their distal attachment within the boundaries of the hand. Intrinsic muscles are those muscles that have got proximal and distal attachment within the boundaries of the hand. The main differences are that the hand is adapted for prehension, so for gripping. So consequently the bones are smaller, regular shaped, have a larger range of motion, whereas the foot is adapted for weight bearing. So we have much larger, thicker cortices in the bones themselves, designed for withstanding heavy loads and impact. When we go on to the joints, the other joints of the hand, the joints of the hand that we haven't looked at to date, so not looking at the anatomical wrist joint, not looking at the functional wrist joints, but looking onto the joints between the carpus and the metacarpals, there is a series of synovial plane joints in which the articular surfaces are covered in hyaline cartilage, surrounded by a capsule, lined with synovial membrane, doing all the typical things that a synovial joint does. They are reinforced by palmar, dorsal and interosseous ligaments, and functionally the role of these joints is to permit a small amount of gliding motion. The only exception to this joint is the first carpo-metacarpal joint, so the joint at the base of the thumb itself, which is a synovial saddle joint. Again, it's a typical synovial joint in so much that it has hyaline cartilage, a capsule and synovial membrane around it, but this time the articular surfaces between the base of the first metacarpal that we can see here against trapezium are reciprocally concavo-convex. This structure allows biaxial movement, so it allows the movements of flexion, extension, abduction and adduction, and the whole thing is reinforced by a series of very strong ligaments. Anteriorly we have the anterior oblique ligament, so in this bottom left hand diagram here we can see a ligament passing from triquetral obliquely up towards the web space. That's the anterior oblique ligament. Posteriorly we have the posterior oblique ligament passing from the posterior aspect of triquetral up to the web space, attaching eventually onto the metacarpal, and these two ligaments meet in the web space of the thumb itself. Laterally, we have the radial collateral ligament, or the lateral collateral ligament. Now, the oblique ligaments are important because what they do is, as we take our thumb across the palm of the hand, so as we adduct the thumb, tension in the oblique ligaments leads to rotation of the metacarpal. This is a conjunct rotation and has the effect of rotating the thumb round to meet the other digits, to oppose the other digits. So if we start off with the thumb abducted and look at where the nail bed is pointing, we can see that it points very much posterolaterally. As we take the thumb across the palm of the hand, so we adduct the thumb, we can see that the thumb is rotated round by about 90 degrees, and this time the nail bed is facing anterolaterally. Moving further up the hand, we have a series of typical synovial condyloid joints. Condyloid joints being modified ball and socket joints. So we've got the rounded head of the metacarpals articulating with the concave bases of the proximal phalanges. So over here we can see the proximal phalanx. We can see the proximal phalanx sitting on the metacarpal head. This is a biconvex structure the metacarpal head is, and the biconcave base of proximal phalanx. Typical synovial joints, it has a very large area of hyaline cartilage to allow for a large range of motion. They permit the movements of flexion, extension, abduction and adduction, and they're surrounded by a loose capsule which in turn is lined with synovial membrane. They are reinforced by a pair of very strong collateral ligaments, and here are the ligaments. These are the collateral ligaments of the metacarpophalangeal joints, so the joints can move into flexion, extension, abduction. Now these ligaments pass from the tubercles on the posterior part of the sides of the metacarpal head. They fan forward to attach onto the sides of the phalanges. They have the effect of becoming taut when the wrist moves into flexion, when the fingers move into flexion, or metacarpophalangeal joints move into flexion, which has the effect of drawing the digits together and preventing them from abducting. Point to note also that anteriorly on the palmar surface we have a fibrocartilaginous thickening in the capsule itself, known as the volar plate, and the volar plates are then held together by the transverse palmar ligament here, and the volar plates are there to protect the metacarpal heads when the fingers are in extension. As the fingers move into flexion, the volar plates slide down onto the metacarpal shaft, and the posterior aspects of the metacarpal heads are protected by the dorsal digital expansion. Moving further up, we have the interphalangeal joints. These are typical synovial hinge joints, uniaxial between the bases of the more distal phalanx and the heads of the more proximal phalanx. They're surrounded by hyaline cartilage, they're covered in hyaline cartilage, and the joint in turn is surrounded by a capsule and lined with synovial membrane. They are typical synovial hinge joints, so they're reinforced by a strong set of collateral ligaments and permit motion only into flexion and extension.